So we're just back in the Excel document now, book 2, that we created in the previous event. A few pointers about the sheet. So we use red for really important keywords. These are just personal choices, but we like the readability this gives the model. We use violet for chemical components. We tend to separate chemical components of the custom variety from solvents. There's a lot of information about solvents built into our tools, so we categorize them separately. It means you don't need to provide as much information about a solvent as you would about a chemical component. The green information here is just comments for your colleagues to sort of help them understand what you're doing, what you were thinking when you put together your model. So these will not be read by the software. That's the components list. Pretty simple. If you want to add a component, you just make some space, insert a component name, provide a molecular weight. The process sheet is really the sheet that determines what model building elements are present in the system, and we're going to develop that a little bit further now to make this initial model do something. So again here, red for the important keywords, violet for the components. The names should be consistent across all the sheets. Black for sort of more neutral variables that relate to the phase as a whole. One new color you'll see here is blue. We tend to use blue for the major model building elements in the system. So here we just have a phase. You'll see that it's a liquid. We are indicating the units in which we'd like to see information about this phase represented. Inside Dynochem, everything is calculated in SI units, but you can use any sensible unit for your variables. There's no need for you to do units conversion. And the plot keyword here just means, yeah, we'd like to see these three responses plotted whenever we run this particular model. Finished means that's the end of the model. So I'm going to show you how to quickly convert this into a model where we're heating the solution. And we can do that with just a few clicks by going back to the process menu. And then there's a whole bunch of options here now for different elements we could add to the model. We'll use some of these later, but I'm just going to go to heat transfer and say add a jacket or a coil with typical inputs. And that is going to just insert another paragraph in my process sheet. It's going to push down the finished keyword. Some more red, blue, black text will appear. Some green comments out to the right for my colleagues will appear. But basically this has created a stream called jacket, which is going to have heat transfer fluid in it. And really jacket is the jacket inlet, jacket out is the jacket outlet stream, which will be at a slightly different temperature to the inlet stream. And cool and heat are synonyms. Whether it cools or heats will depend on whether it's hotter or colder than the phase it's cooling or heating. So it's in contact with solution, and the solution temperature versus the jacket temperature will determine whether it heats or cools. I'm going to go with 80 degrees on the jacket side just to get started with something happening. And I'm also going to indicate that there is a little bit of contact, a little bit of agitation and wetted area between the jacket and the liquid. Just put a few numbers in there to represent that. And I'm going to return now to simulator and simulate this system. So if you're following along, please kind of do all those clicks, hit the simulator button. Once again, you'll see the software reading the Excel workbook. If there are no inconsistencies, we'll be back into experiment 1. And once again, we can run experiment 1, simulate experiment 1 using right click and run or F6 or the play button. And now we'll still see that there's not much going on with the component amounts yet, because we're not really doing anything that would change the component amounts in this model. But if we look at the temperatures, we'll see that, okay, there's some variation now. The temperature begins at around about 45 degrees. I'm pressing down with my left mouse button to see that. on the green curve, and then over a period of about 1 hour it rises to 80 degrees C. So we're now calculating the heat up time for this particular batch of material. Similarly, if we look at jacket temperature, it comes in at 80, jacket outlet leaves at almost 80, meaning there's plenty heat transfer fluid and therefore not much of a change in temperature as the fluid flows through the jacket. We could make some quick changes here now in Simulator, just showing you a slightly more advanced feature. So we could change, for example, the initial temperature. Just click into the cell, change the value, press return, and we could then press play to rerun the simulation, and we'll see that this of course begins at 20, takes a little bit longer to get up to 80 degrees C. Please join me in the next video. I'm going to then go on to talk about the Scenarios tab and the Data tab, and then we'll continue to add elements to this model.